Section 5.2 is introducing word problems related to rates and unit rates. So what we've been practicing so far in section 5.1, we're going to build on that. And within this section now of 5.2, we're going to be looking at more word problem type questions with our rates and unit rates. So by the end of this section, be able to solve problems that involve rates and unit rates. And as far as vocabulary goes, we're going to continue using our words of rate and unit rate, and we're also going to introduce this idea of speed. And we'll see speed a little bit later on in our notes, and you guys should be familiar with speed as well, maybe from past math classes or in science. So taking a look here at our first learn, being able to solve simple word problems involving rates and unit rates. So given problem number 1, a unicycle wheel makes 196 revolutions in 7 minutes. This is a rate given to us because we have two different quantities with different units. We have revolutions and minutes. In part A, at this rate, how many revolutions does it make in 1 minute? So if the unicycle wheel makes the same number of revolutions every minute, we want to know what is that number of revolutions for just 1 minute. Well, really what we're solving for here in part A is our unit rate. So let's find our unit rate. If we take 196 revolutions divided by 7 minutes, we plug in 196 divided by 7 in our calculator, we would find that it can make 28 revolutions in 1 minute. So 28 revolutions, that is our unit rate. In part B, at this rate, how many revolutions does the unicycle wheel make in 15 minutes? Well, now that we know it makes 28 in 1 minute, in part B, we're looking at groups of 15 minutes, so I need 15 groups of 28, or 28 times 15. And when I multiply those two together, 28 times 15, my answer comes out to be 420 revolutions. So in 15 minutes, this wheel can make 420 revolutions. So when given a rate and being asked to find some other amount of one of those units, it's super helpful for us to use that unit rate or solve for our unit rate first in solving the other problem. And we'll see something like that here in problem number 2. So a machine can pack 70 boxes of spaghetti in 5 minutes. At this rate, how many boxes of spaghetti can be packed in 8 minutes? Well, I can't just go from 5 to 8. So maybe I need to find my unit rate first to know how many boxes can be packed in 1 minute. Then I can find 8 groups of it. So let's find our unit rate first. So 70 boxes in 5 minutes. When I divide 70 by 5, my unit rate comes out to be 14 boxes per minute. So for 8 minutes, I have 8 groups of 14. So I'm taking 14 times 8. And in total, the machine can pack 112 boxes. So we started with a rate, found our unit rate, then multiplied our unit rate by the other amount that was given to us. Now looking at Learn 2. So being able to read a table to find the information to solve multi-step rate problems. So given the table off to the side, being able to solve the problem given the situation over here. So in problem number 3, the table shows the parking rates at a parking garage. Ben parked his car there from 9 a.m. to 2 p.m. on the same day. How much did he pay for parking? So if we look at our table, it's telling us that on the first hour, it's going to be free. It's not going to cost Ben any money to park the first hour. The second hour that he's parked there, it's costing him $1.75. Then after his second hour, every hour after the second hour is going to be $2.50. So given this information over here and the time frame of which he was parked, we're going to figure out how much he paid. So from 9 a.m. to 2 p.m., that's a total of 5 hours. So for 5 hours of parking, we want to find what the price was. So the first hour, hour 1, cost him $0. Hour 2 cost him $1.75. Hour 3, we're moving on to the next part on our table, was $2.50. Hour 4 was the same, $2.50. And hour 5 was also $2.50. So what we've done here is we've identified what amount was paid for each hour. Hour 1 was 0, hour 2 was $1.75, hour 3 was $2.50, $2.50, and $2.50. So to find his total, we want to add all of these together. So $0 plus $1.75 plus $2.50 plus $2.50 plus $2.50. When we add all of those together, it comes out to be a total of $9.25. So Ben paid $9.25 for parking. Looking at another example with a table here. The table below shows the charges for renting a bicycle. Tom rented a bicycle from 10 a.m. to 2 p.m. on the same day. How much did he pay for renting the bicycle? So in this table, the first hour is going to be $3. For every additional half hour, it's going to cost $2.50. So for 30 minutes or half of an hour, it's going to cost $2.50. If we know this information, 1 hour is going to be double this amount. So we could think about 1 hour being equal to $5, because if we look at our time frame here, he's not using a part of an hour from 10 a.m. to 2 p.m. We're going to come out to a whole number of hours. That let's work with this number as opposed to working with our $2.50. So from 10 a.m. to 2 p.m., that's a total of 4 hours. So we have hour 1, hour 2, hour 3, and hour 4. It was $3 for the first, $5 for the second, $5 for the third, and $5 for the fourth. Again, we're finding a total. We want to add all of these together. 3 plus 5 plus 5 plus 5. And when we add all of these together, we get $18. So Tom had to pay $18 for renting the bicycle. Looking at Learn 3, being able to compare unit rates here for a given situation. So Andy needs new batteries for his video game controller. He's trying to decide between two brands. A package of two brand A batteries costs $3.20. And the manufacturer claims the batteries will last 20 hours. A package of two brand B batteries costs $2.80. And this manufacturer claims that the batteries will last 14 hours. So our job is to decide which battery Andy should buy and then back up or justify our answer with an explanation. So most of the time in the unit rate problems that we've been working on, we've focused on finding maybe dollars per hour or dollars per minute. But if we think about this situation with the batteries and thinking about in your own life, you're going to want a battery that's going to last longer per dollar. So for every dollar that Andy's going to spend, he's going to want to have the most battery life from that battery. So we have to think about this as hours per dollar. So let's find our unit rates here for both brand A and brand B. So brand A, we have 20 hours for $3.20. If I divide 20 by $3.20, battery A is going to last 6.25 hours for $1. With brand B, we're going to do the same thing where we're taking our 14 hours divided by our $2.80. When we divide those, we get 5 hours for $1. So looking here between brand A and brand B, we have to shift our thinking in this example away from the better buy or the cheapest option, because both of these are looking at how much for just $1. Our dollar amount is the same. We want to pick the one that's going to have the most hours for $1. So taking a look here, 6.25 is bigger than 5. So brand A is what we should buy, or what he should buy, because there are more hours of charge per dollar. It's going to last longer per dollar. And looking at our last learn here in Learn 4, being able to solve problems involving speed, distance, and time. Over to the side here, we have this super helpful triangle that we can use when solving for one of the three pieces here, where we're solving for distance, if we're solving for speed, if we're solving for time. We also have this written out here for us as well. Okay, the relationship between distance and time here, if I was going to be solving for my speed and I'm left with my distance and time, because these are on top of each other, that means that I'm going to be dividing if I was solving for speed. Same thing happens if I was going to be solving for time. I don't know my time and I have my distance and I have my speed. I'm going to divide as well. If I'm solving for my distance, I'm going to take my speed times my time, which we can see here too, that if I didn't know my distance, I would take speed times time. Now these are just a bunch of symbols right now. As we look at problems 6, 7, and 8, this will make a little bit more sense of how we plug these into our formulas. So looking at problem 6, Mr. Lobbins drives his truck at a speed of 45 miles per hour. In part A, at this speed, how far will he travel in 2 hours? So we know our speed and we know our time. We're solving for distance or how far something happens. So if I don't know my distance, that means I'm going to take my speed times my time. So I'm going to plug in my 45 speed times my 2 hours. When I take 45 times 2, the distance he traveled was 90 miles. In part B, he's still going at the same speed. How far does he travel now in 5 hours? We're finding that distance yet again. So I'm taking my speed times my time. So 45 times my time of 5 hours to find that he would have traveled 225 miles. Looking at the next one, Alex ran around a soccer field at a speed of 8 meters per second. How long did it take him to run a distance of 96 meters? So this time we have our speed and we have our distance. I'm solving for my time. If I don't know that, let's say I'm crossing that out, I'm left with my distance and my speed. I can see here that I have to divide these to be able to solve for my time. So my time equals distance divided by speed. So we're going to take 96 divided by 8 and solve that it would take Alex 12 seconds to run around the soccer field. And the last problem, a van traveled 28 kilometers in 4 hours. We want to find the speed. So we're given our distance and our time. When we're solving for speed, if I look back up here at my triangle, I'm going to cross out speed. I see I have to take my distance divided by my time. So I'm going to plug in my numbers. I have 280 divided by 4. And when I divide, I'm left with 70 kilometers per hour. So speed is an example of a unit rate. Be ready to come to class with questions if you have them. Feel free to rewind at any point if you need to catch something again.